As we have seen in our previous module about the axial flow impellers, this module again we will talk about axial flow impellers. So axial flow impellers, as we have already discussed, that use when the mixing shear sensitive process such as crystallization and the precipitation reactions. So because sometimes when the product is based upon the crystallization and the precipitation is required, so that's why sometimes when there is the chance of the breakdown of those crystals, we cannot use the radial flow impellers. So that's why we use the axial flow impellers. So they are widely used in case when we culture the animal cells. So when we use the fermentation process just to culture the animal cells, so then there is a need of use of axial flow impellers. So due to the low shear characteristics generally makes the axial flow impellers ineffective at breaking up the bubbles. As I already told you that axial flow impellers have not as much as the shear effect as the radial flow. That's why the axial flow impellers are unsuitable for the bacterial fermentations when there is more aerobic reactions or more aerobic conditions are required. So that's why the axial flow impellers are not recommended when we have to use the bacterial fermentations. So in case you can see in this slide and the diagram that when the axial flow impellers move, that what is the direction of the flow of the medium inside the fermentation vessel. So with the axial impellers, the liquid is pushed down. You can see here easily that when it goes in first stress, then the media pushed down, and then with the force that tend to go upward. So that's why there is a gradual cyclone type movement of the medium inside the fermenter. So this slide actually shows that how the axial flow impeller work. So as concerned the low shear conditions that is achieved by pitching the impeller blade, you can see in this picture that is mostly look same as we have in our ceiling fan blades. So that's why there is low shear conditions. So that's why they tend to have a less breakdown in the air bubbles. So when there is a problem in radial flow impellers, when there is a maximum shear, but in case of axial flow, when there is a less shear, and we want to use having a less shear, and then we have a maximum mixing of the air bubbles or air into the liquid medium, then there is a choice than having such another kind of the impellers. So that is known as the impeller that mostly used in such cases, that is intermig impellers. That is actually the axial flow impellers. You can see in this picture, the center of this highlighted red line, you see that is basically designed just like the axial flow impellers, but on the edge of this there is another rotating design that when the axial flow impellers moves, that push the medium toward the bottom of the vessel, but these moved and then they help to break down the air bubbles into the smaller, just to increase the surface area. So that is a problem just to check the problem that exists in axial flow. So by this kind of interming impellers, we can avoid that problem of low shearing effect. So the agitation system has, as we know, that have two impellers. That mixing of the bottom impellers has a large axial flow section, and the tip impeller contain a finger-like extension which create a turbulence wake for breaking the bubbles. So as the high shear region exists only at the tip, so the overall shear condition in the reactor are lower than would be generated by the radial flow impellers, such as in case of the Russian turbine. So the intermig impellers are used widely for the agitation and the aeration of those fermentation in which mostly the filamentous organism, as we can say that fungal fermentations. So in this slide you can see there are different types of the impellers: disc turbine impellers, how they look like, and then van disc, when such kind of that. So open turbine. So these are different designs of impellers which are mostly used in the fermentation. So here you can see that three-dimensional diagrams of 6-blade disc turbine and 6 curved blade. Just the difference between these two impellers are, this turbine have the straight blades, but in the lower case you can see there is a curve of the blades. So minor difference between these two, but these two categories mostly come in the radial flow impellers. In this diagram you can see the axial flow impellers having different shape of the blades. So these are the different impellers which are used in designing of the fermenter vessels. So because the mixing in a fermentation process is very critical, so that's why while designing the fermentation fermenter, then we have to be very critical while fixing the impellers.